We need to be able to graph this square root function. So I've said it many times, I need you to identify h and k. What's h? -2. That means that you're going to be moving 2 units in the negative direction, which is to the left. K is what? +4, which means you're going to be moving 4 units up once you actually get your coordinates. So after you identify h and k, what I would like you to do is to box this and ignore h and k. So what you're going to do is pretend that your function is y equals the square root of x. So it'd be a great idea to make an xy table and just pretend that you don't have an h and k. Pretend it's just that, y equals the square root of x. So when you plug in some numbers, plug in 0, you get out of 0 because the square root of 0 is 0. The square root of 1 is 1. When you plug in 4, the square root of 4 is 2. Plug in 9, the square root of 9 is 3. So we have these coordinates of the parent graph. I want to graph the coordinates of the parent graph. There they are. You have 0, 0, 1, 1, 4, 2, and 9, 3. That's the parent graph coordinates. Now, we don't want to actually draw it because that's not the graph that we want to graph. We want to graph including h and k. So we're going to modify these coordinates by moving according to h and k, which is 2 to the left and 4 up. So when we go 2 to the left and 4 up, 1, 2, 1, 2, 3, 4, right there. And the next one, 2 to the left and 4 up, 1, 2, 4 up. And then the other one, 2 to the left, 4 up, right there. And the last one, 2 to the left, and 1, 2, 3, 4 up right there. So your actual graph is the one with the blue dots, starting here, going through these points. So ladies and gentlemen, you get 2 points for that, and you also get more points, like down here, number 18. It says state the domain and range of number 14, 15 above. So we need to state the domain and range of this graph. Now for domain and range, you truly need to understand your hk value, which is -2, 4. That's your beginning point of this curve. So that tells you where your graph is at in terms of x and y. So if you want to state your domain, you're going to say x is, and you got to think x is left and right. So is this graph to the left or is it to the right? It's to the right, which means it's going to be x is greater than a certain value. X is greater than what value? See, here's 0, here's -1, -2. So -2 is where the x begins, and it's going greater than -2 if you're just looking at it from left and right. So x is greater than or equal to -2. That's your domain. How about your range? The range would be what? Y is what? Greater than or equal to 4. Now, why is it greater than? Because you have the y value of 4 right here, and it's definitely above the y value of 4, not below. So if it were opening down, then it would be less than or equal to 4, but it's opening up. It starts at the y value of 4, and it goes up forever. Taking a look at this next one, graph y equals -2 square root of x plus 2 plus 9 on the outside. Ladies and gentlemen, what happens with this? If you think about the parent graph, what happens with it when you put a negative in front? It goes down, right? It gets reflected on the x-axis, and then the 2 causes it to be a vertical stretch, causes it to be a little wider because it's greater than 1. So the negative causes a reflection on the x-axis, so instead of going up like this, it's going to be going down like that, and the 2 causes a vertical stretch. That's just something that you should know. Let's jump right into it by identifying h and k. So what's h and what's k? What? 9, okay. And once you identify h and k, ignore h and k. Notice I'm boxing in everything except the h and the k. So you ignore h and k, and you make a xy table ignoring h and k. So here's my XY table, and if I plug in 0, right in here, it's going to say the square root of 0, which is 0, and 0 times negative 2 is still 0, right? When I plug in 1 right in here, the square root of 1 is 1. 1 times negative 2? Negative 2. When I plug in 4, square root of 4 is 2. 2 times negative 2? Negative 4. And last but not least, let's plug in 9. The square root of 9 is 3. 3 times negative 2? Negative 6. Okay, so we have these coordinates. This is my parent graph, ignoring h and k. So I'm going to get these coordinates, 0, 0, 1, negative 2, and 4, negative 4, 9, negative 6. And I'm going to plot them on the xy plane. So here are my coordinates to the parent graph, ignoring h and k. I'm not going to draw my curve there. Notice that it's wider. It got vertically stretched because of the value of 2. It got reflected down instead of up because of the negative sign. But I still don't want to graph it because that's ignoring h and k. I need to include h and k. So h, we said, was a movement 2 in the negative direction. That's 2 to the left. And k is positive 9. That means 9 units up. So I need to take each of these coordinates and move it 2 to the left and 9 up. So if you do it correctly, 2 to the left, 9 up, you'll get right there. 2 to the left, 9 up, you get right there. 2 to the left, 9 up, right there. And 2 to the left, 9 up, right there. So we have our new graph. Let's actually graph this guy, starting at this point, going in this direction forever. Okay? And now let's identify our domain and range. How about our domain? X is what? Greater than or equal to? What's your x value of h and k? Negative 2. So x is greater than or equal to negative 2. Right? Your hk value is negative 2, positive 9. So x is greater than negative 2. So if you're at negative 2 on x, here's negative 2 on x. Is your graph to the left, or to the right? It's to the right, so x is greater than or equal to negative 2. Let's talk about range now. The range is your y values, and what about y's? Less than or equal to what? To 9. Perfect. All right, so that domain and range will be asked as a separate point down here if you check it out. It says state the domain and range of 16, 17 above, so state the domain and range of that. You get an extra point for domain and range. How about this down here? Number 20. It says state the domain and range of y equals negative 2/3 square root of x plus 17 plus 19 without graphing it. So the domain of that guy would be x is what? Is it greater than or less than? You got to visualize. First of all, what is the hk value? Negative 17, comma, positive 19. So visualize that on a graph. Negative 17, positive 19. Is the a value opening up or down? I mean, is the a value causing it to go up or down? Down, right? Because it's negative. So you know that if you did like a quick sketch on the side, do a quick sketch here. So negative 17, that's way over here. Positive 19, way up here. And we know that instead of going up like the parent graph, it's opening down. So somewhere up here, it's going like this, right? At the coordinate negative 17, 19. So what could he say about your domain? Greater than or equal to what? Negative 17. What could he say about your range? Y is what? Less than or equal to 19. So you get a point just by thinking about it without having to actually graph it. Of course, a sketch would help. And the final question on tomorrow's quiz, true or false? The transformations from the parent graph y equals the square root of x to the new graph y equals negative 3 halves x is that it gets reflected over the x-axis and gets vertically compressed by 3 halves. Is it true or false? True? What's false about it? So, if you look at this a value of 1 and this a value of negative 3 halves, doesn't that negative cause it to reflect over the x-axis? All right, so that's true. It doesn't get vertically compressed? Why not? It's greater than 1, right? The fraction is greater than 1, which makes it a vertical stretch, not a vertical compression. So, if I were your math teacher and I was giving this quiz tomorrow, I'd go back and change something about this, which I am. So make sure that you pay attention to the words. If it says reflected over the y-axis, it's false. If it says vertically, so you got to pay attention to the details there. And that's what I have so far for tomorrow's quiz. 2 videos. You guys should be ready if you watch them.